Hello everyone, my name is Salahuddin Sheikh Khalil and I am a computer engineering student at Cumhuriyet University with the student ID number 2022-123-164. And today I would like to introduce you guys for our project for IoT and microprocessor classes. Our project named Cubotino. It's an autonomous Rubik's Cube solver robot that embodies the principles of IoT by integrating hardware and software to deliver a seamless user experience. And it's fully 3D printed. It delivers IoT technologies like Raspberry Pi for efficient computation and control. And it's designed to solve Rubik's Cube without requiring special modifications, and it serves as an accessible, affordable, and educational platform for robotics and IoT enthusiasts. So our project scope focuses on making robotics more accessible and affordable and ensuring scalability with minimal mechanical variations, also keeping the design compact and fully 3D printable, and providing detailed instructions for learning and experimentation. When it comes to overview our project powered by Raspberry Pi Zero 2 and Pi camera, also designed to be small, efficiently detects cube status and solves it in under 60 seconds. And when it comes to key features, our project uses Python as OpenCV for computer vision and detecting the colors, and requires standard Rubik's cube. We have this cube 3 by 3. Our robot is just solving these type of cubes. It doesn't solve any other shapes. And also, it's small and affordable and user-friendly. When it comes to construction overview, we make there's design principles, of course, for it. Low-cost components, compact design, suitable for home 3D printers, simplified mechanics using servos and a titled cube holder, and fully 3D printable parts to reduce dependency on external tools. These are the 3D printed parts that we printed at home. There's the structure, top cover and cube holder, lifter and servo axis components, designed for easy printing without support structures, uses PETG filament with detailed print settings, and a lot more. There's also the purchased components. We bought these hardware essential components for the project. We got the Raspberry Pi Zero 2, Pi camera version 1.3. Also, there's the servo motors. Each one, we used actually two servo motors, each one for 25 kilogram, and a micro SD card and a display for showing the cube status and the solving steps. And there's also the lid module and the touch sensor and a lot of more other things. There's also set up the Raspberry Pi. We had to install Raspberry Pi operating system legacy for compatibility. There is also configuring SSH, Wi-Fi, and virtual environments, setting up libraries like OpenCV, GPIO, and others, of course. And when it comes to PCB, the PCB connects the Raspberry Pi to servos, lid module, and display. Also, there's the PCB double face board with clear wiring guidelines, also designed for efficient signal flow and easy assembly. When it comes to assembly steps, it's really easy to make. Attaching servos and cube holder, assembling the top cover and lifter mechanism, connecting components to the Raspberry Pi and finalize wiring, securing all parts and perform initial tests. And there is also the cube manipulation. There's two moves for the cube manipulation or robots. The flipping uses gravity and servo angles to rotate the cube, and servo control ensures precise positioning for each move. When it comes to tuning, adjusting servo angles and timers for optimal performance, and fine-tune camera parameters for accurate cube state detection. Operation instructions, you have guys to just place the Rubik's cube on the holder, powering up the Raspberry Pi and servos, initiate solving by touching the touch sensor that we have in our robot, and that's it for operation instructions. We used computer vision libraries, OpenCV for cube detecting and color detecting, and state reading. Also, LED module ensures consistent lighting for accurate recognition. For the solving algorithm, we used Koshimba two-phase solving algorithm. It converts detected cube state into optimal move sequences. When it comes to troubleshooting, there's a servo misalignment problem. We had to just adjust angles via script. Also, there's lightning problems, ensuring uniform light conditions. Also, wiring errors. We had to double check connections and pinouts. When it comes to safety notes, we had to use isolated USB power supply to ensure safety, of course, and we had to always supervise the robot during operation. Okay, the educational benefits. We had a lot of benefits learning. We learned a lot of things making this project. Introduction to IoT and computer vision, practical experience with Raspberry Pi and Python. It also encouraged us to made it creative problem-solving skills. And we had a lot of challenges while making this project. There's the cost reduction through simplified design, compactness without compromising functionality, also balancing affordability and performance. It's the biggest challenge we had. And also future improvements. We have a plan to improve our project by developing a medium versions with enhanced features and exploring advanced automation techniques to make it better and better. There's also the code setup. There's scripts for cube state detection, servo control, and solving, and Python libraries and the dependencies used. The project was made by our team. These are the members of our team. And now I would like to hand things over to Ziad Hassan, who will present our robot and walk you through how we develop the project from A to Z. He will also introduce you guys to the rest of our team and explain the specific tasks each member contributed during this project. Thank you guys for listening. Hello everyone again. I would like to show you guys the website that we worked on for our project. So we worked on this website using React.js and also using Flask for connecting the OpenCV model to our front-end application. Here's the code of app.python. This is the Flask application. Here's the model, color detection. Here's for color ranges, RGB. And here is index.html that the Flask application works on, the webcam here. Here's the video feed. There's also the buttons that you guys see. And here is the front end code. We used React routes for making multiple pages, project page, team page, contact page. And let me guys show you the website right now. Okay. So here's the home page. It's a button that gets us to the project page. Here's another button for some information about the inventor of Rubik's Cube, Erno Rubik. The project page, the used components, Raspberry Pi camera, servo motors, the PCB designs. There's also the 3D parts. I can show it to you guys by 3D viewer. Every single part that we use in our project, it's in here. And here's our team for IoT and microprocessor. This is for contacting, writing username, email, and message. And we get your message by using email. And here's the interesting part, the solving page. Here's the camera, hello. First of all, we have to make the white on top and start with green. See how it takes the colors. I will capture the frame right now. The second face, third face, fourth face. Now, after the four faces are done, now we will capture the white face. Here's the white, while the green on bottom. Now the yellow, we will capture the yellow face and the green is on top. After that, we finish the scanning. Now we will get the solution. Here's the solution of our Rubik's Cube. Every single letter of these are represented here. After making these steps, it will solve the Rubik Cube. Thank you, guys.
Hello everyone. This is our project, Rubik Cube Solver Robots, and this is the Rubik Cube that we are gonna try to solve using our robot. My name is Ziad Hassan, and as you can see here, this is my student number. I'm responsible for the Python code, the hardware, and some settings and making the robot works. Salahdin is he's responsible for the software and basically the website that we made. Two of my friends, Muhammad Bakir and Abdullah Al-Gindi, they are responsible for the PCB card Muhammad Ali. He is responsible for the Raspberry Pi installing the Raspberry Pi system on the SD card. And my other friends, Ahmed and Abdelaziz, they are responsible for the 3D print and actually making the assembly for the robot. All right. This is the our introduction. It's basically a robot that uses two servo motors and Raspberry Pi Zero 2. And using these simple things, we are actually managed to solve our Rubik's Cube. Okay, let me first, this is our things that we're gonna go for. And firstly, with the things we used, this hardware stuff. Okay, this is all of the list of the things we bought, but I'm just gonna directly go for the explaining the stuff. The first thing is the servo motors. We use the high torque servo motors, and it's actually because it has a 180 degrees. This is what you actually need with a frequency pulse of 500 to 2500, which is actually really useful for us. And also, it doesn't need a really high voltage, which is became really useful for our small project. Second is the Raspberry Pi Zero 2. And we actually didn't need a powerful Raspberry Pi 3 or 4 because the project is not really that complex. It's so actually a Raspberry Pi Zero 2 was really enough for us. I'm gonna go to the pins that we used. The first is the second and the fourth, which is basically the pins for the power. Let's use a 5 volt power input and 25 and 6, which is the ground pins. All right. And after that, we used the number 8, the GBI 14 TX, which is basically for the LED. That's let us know that the Raspberry Pi is on. Second, there is two others that we use, number 12 and 32 and 33, three of them. The first one is the for the LED. So this one is number 12 is for the LED. So the camera, Raspberry Pi camera, will need a little bit of lighting in order to get the correct colors for the Rubik's Cube. And we have number 32 and 33, which are basically for the two servos that we used. So one is going to be number 23, which is the top cover servo, and the other is number 33, which is the cube holder, which is rotates the cube 90 degrees. And last is the 37 pin, which is for the our touch sensor. The touch sensor is we use for, starting the scramble and solving. And now for the P camera, it's not actually something really not really high quality camera. It's a low quality camera, 5 megapixel, which is very enough to capture the colors for it, for the Rubik's Cube. And now for the PCB card. It's a little bit complex, but actually it looks complex, but if you look through, it's not really that complex. And these are some things, some notes. We used a double shift. How do you call it? A double face card, which is actually like this. I'm going to explain it from here. As you can see, it's actually really simple. It's not that hard. We have basically a regulator here, which is going to make the current will lower the current for some special things that we have in our things. For example, for the ground, it takes here and number 6, number 8, as we said, it's for the LED. So it's a regulator for the LED. Other thing is we have two capacitors here. There's three capacitors actually. Three capacitors we use, and it's actually for the servo motors. When the power goes off, it just gives us a little bit more current for the servos in order to keep running. And these 8 pins actually, in the beginning I was gonna use a LCD small screen for and the status for the cube and how much percent is solved and what's it doing, what's it reading. But we had a problem with this section, so we actually kind of canceled this section. So we're not gonna use 13, 14, 19. It's all for the LED screen, but we canceled this section, so we're not gonna actually use it. As you can see here, number 12 is for the LED. We have three here. These three are for the LEDs. These three ones are uh, for the what do we call it? This touch sensor, and three of them here are for the servo motors. Three are for the bottom servo motors, and the other three are for the top servo motors. Um, yeah, and if you can see here, let me delete that clear. Um, if you take a look here, this is for back. How is it called? As you can see, it's more details. This is for the display that I said before that we already canceled this display because we had a problem ordering the screen. And this is the regulator. And we have here, this is for the LED, this is for the touch sensor and the holder, servo cube holder, which is the bottom servo, and the other one is for the top servo. As you can see, symbol three inputs. There's the PWM, the 5 volt, the ground, same here, and actually same for the others. And for here, for the touch sensors, we're gonna take it from the regulator because it takes 3.3 volt, which is gonna be really equality because if we used that 5 volt, it will have a problem in the touch sensor. This is why we use a regulator here. Okay, this is basically our PCB card. We could have ordered it ready from others, but it will take a lot of time, a lot of also money. So we decided to make it by ourselves. We had a little bit of problems, but we managed to do it in the end. Uh, and now for the editing the operation system for the Raspberry Pi, which was really, really easy section. We just have a link here that you can go for, and you're gonna download the imager for the Raspberry Pi imager. The first thing we're gonna choose the device, which is the Raspberry Pi Zero 2 here. Secondly, we're gonna use the operation system, which is we are using the OS Legacy 32 bits. Um, and this we're gonna choose our storage, and storage is basically our small SIM card. Let me show you. This is the SIM card, it's really small. We're gonna choose it here, and you're gonna actually hit yes, and it takes about 10 minutes, so don't worry if it takes much longer, it's not a problem. And at least you're gonna have after you download the operation system on the Raspberry Pi, you're gonna just input, and here it is. You have your operation system ready. Now for the 3D printing part, it was kind of a part. It was a really nice part. So it took like the structure is the biggest one. It took like 14 hours. The top cover 12 hours, 5, 3.5, 3.5. So it was like a total of 3 days of printing, 4 days maybe. And here are some notes for the printing part. We just used a PLA Plus, which is you can get it from anywhere, with of course a 30% infill, which is very useful to have a good structure for the robot. Uh, and here you can see all of the structures, and I will attach all the STL files for the project, and you're gonna get to print your own if you want to make it. This is the structure, the top cover, the hinge, the base plate front, which is the underneath the robot, and this is also the placement rear. And this is the cube holder that rotates the cube. And we have a cube lifter, the PCP cover display, the P camera holder. This is the servo axis and the P camera frame. That's it. Now I wanted to show you the robots. As you can see, we have here one servo motor. The second is here. And here we got the camera and the LED. As you can see, it's from here. This is the LED and this is the camera. And here is the Raspberry Pi alongside with the PCB card, just together. And here is the, as you can see, we have the touch sensor in here and the screen that we are not currently using. And this is the power supply type C, just coming from here. And it gives the power for the robot. The assembly steps are really simple. As you can see, it's here. Everything is covered in details. And yeah, this is the final look for the robot. And now we're gonna show you how the robot works. As you can see, I have scrambled the cube right here. I'm just gonna now give it to the robot. And just right here, as you can see, there is the touch sensor. Now I'm gonna touch it. Just by touching it, as you can see, it's gonna read all the 6 faces right now. It's now reading the faces. After finishing reading the faces, it will upload all of them to the Python library, Kushimba, and it will receive the solving tip, and it will start solving. Now it's starting to solve the Rubik's Cube, as you can see. Only using two servo motors, one right here, and the other is in the back. The Kushimba library is actually making it to solve it at the least number ever. So as you can see, it's finished. Yeah. Now it's doing a little bit of a dance to show you that it's finished solving the Rubik's Cube. As you can see, all of them is solved. Yeah. And now I can start another cycle by touching the touch sensor, and it can do another solving.